So if you're interested, this is a one and done. It's the only time it's going to happen. And I thought that I'd get started by saying, over the years you've been seeing the Boeing demo, the Boeing story, and hearing about how Boeing came to be. And Boeing's cool and everything, but underneath all that is the multitasking kernel. And this is what that story is about, is where that kernel came from. And then kind of what happened after that. Where did it go? Why was the original Amiga DOS so crappy? Those kinds of things. So that's the full story, and that's what I want to tell today. So let's see, we got see the slides work here. Oh, being Halloween. Hey, Dale, check it out. Did you even know these pictures existed? I found these when I was going through a pile of photos. Yeah, those are great, aren't they? Is that 83 or 84, do you think?
Yeah, from where so yeah, I agree. I think that's 83. Or, well, before Commodore.
Okay, switching microphones. All right, so you can see Dale in this photograph here, and two people that need to be recognized right off the bat, Jay Miner and Bob Pariseau. And a lot of people don't know Bob Pariseau much. Bob was the head of the software development, so he's VP of software at Amiga Computer. And he's the one that put together the team. He's the one that hired me, hired Dale, hired the software team, and he was an incredible guy. I had a lot of respect for what he accomplished in Amiga, and he doesn't actually get enough credit. And if you're wondering what's this big black thing, that's the foam bat that's so famous for the Boeing sound on the metal door. So let's advance here. So what I'm going to talk about is the timeline, which starts out way before Amiga. This concept of a microkernel was new back then. If you are familiar with older computers, the 64, Commodore 64, and Atari, and all those other machines, they didn't really have a concept of an operating system. Yeah? More? Louder? Is that better? Okay, I'm getting a signal to be louder. All right. I'll do it like a rock and roll singer. I'll hold it right in front. All right. So microkernel was a new concept, and that was something that came over to Amiga through my background, and I'll be mentioning how that happened. And then, there was a point where I left Amiga and went off and worked for the enemy. I went and worked for Apple, and it was cool because they had so much money compared to Commodore. And then came back to Amiga and did a few projects, and there's history there. I'll go through it in detail. Let's see how long it takes this to come up. Do you have to point this? Oh no, there it is. So long ago. So I've done this full arc now in my life, and it's funny how, your life is like a river, where you get caught in these streams that carry you different places. And long before Amiga, I worked in television, and I worked my way up, through all the different parts of being cameraman, a loader, a technical director, and finally directing the 6 o'clock news when I was still very young. And it came to a fork in my life. I wasn't sure if I wanted to go on and get involved in technology or film. So that was my choice at a young age. Which direction do I go? I loved them both. So I went off to a university. It's right up the street here, Davis, and enrolled in the Double E program at Davis. And that was the same time computers were coming along, and they had a computer science, specialty for your Double E degree, which was a really cool addition. And one of the professors that taught the operating system course at UC Davis was a guest lecturer from Hewlett-Packard, Cupertino. And so I took his course, and he came up to me, at the end of the quarter and said, "Hey, you're really good at this operating system stuff. We'd like to, interview you for a job at HP." So I did that interview. I passed and ended up at HP Cupertino down in Sunnyvale, which is now the Flying Saucer. They mowed all those buildings down. Those really nice buildings got bulldozed. So I ended up on the OS kernel team, which were the people designing the 3000 HP 3000 kernel. They decided to merge the HP 2000 team and create something called HPE, which stood for Hewlett-Packard Executive, which was the kernel of the operating system. And it was at a time when there was a lot being written about making smaller operating systems. Back then, operating systems were large projects, very large. They kept all these paper listings in a cabinet that would take that entire wall over there. That was paper listings for the source code to their operating systems. So I introduced this idea that I've been reading about in some of the journals, is microkernel, and making a real small microkernel is message-based, and it could be multi-processor based too, and it could be even network based, where messages would transfer between different kernels, right? So I presented this paper at Pajaro Dunes back in, I guess it's like 82, I suppose. And, well, actually it's 81, I think. And they didn't like it. And I was really surprised because it was really a good idea. It made, operating system code a lot easier to maintain. And, to build and maintain, made the whole structure cleaner. So I kind of was like crushed by that rejection of my white paper, and I took off and went to the South Pole with HP's blessing. They said, sure, take an academic leave of absence and let us know when you get back. So that's what I did. I did physics experiments down at South Pole, upper atmospheric electrical stuff. So ionosphere, all those kinds of things. There's something called a cusp down there, and the cusp has all these particles that come spiraling down the cusp, and that's studied heavily. It's a very interesting part of the atmosphere. So when I came back, I went over to HP, and they said, hey, we'd like you to come back here. And I was interviewing other places too, and they said, if you come here, you can do whatever you want. And I thought, well, that's a nice offer, because HP back then was different than what HP is, today or even in the last 20 years. HP was the best engineering company in the history of the world. Yeah, here's another HP person over here who agrees with me. Oh, Dale. Yeah, it's Dale from HP also. I've forgotten. And they were amazing. And every engineer wanted to work for HP because they were so good to you. And they had like lab stock, like the size of this room. Imagine that all being parts. And when you interview, they say, those parts are yours. You can build whatever you want with that stuff. It doesn't have to be for work. It could be for home. It could be for hobby. It could be for your friends. Whatever you want to do, that's your stuff. And that's one of the reasons I went to work there, because I just loved that offer. So I returned to HP with the idea that I could do whatever I want. I found a guy that was up at Stanford who was making this little box called the Sun Workstation. His name was Andy Bechtelsheim. And I said, hey, that's exactly what I want, that little bitmap, type box. And he lent me one, and I couldn't believe it. So there's 2 prototypes he has just barely working, and he lends me one. I take it back to HP. He has a manual for it that's 3 pages long, okay? That's the API, 3 pages. I got a couple other guys, in my division to help create fonts, icons. There's a little 3-button mouse. Dale knows the mouse really well because it was an optical mouse that he later marketed. And Windows, and we got this thing working pretty well. So it was a full body GUI. So we were kind of inventing the whole GUI style of computing, and we could not convince anyone at HP to build this box. We went all the way up to the top of HP. The president of HP, we gave him a demo, and he said, yeah, HP should make something like this. But then to get that to propagate back down to managers in the sort of the middle of the company was really tough. And what they ended up doing is they started a whole new division that was called the PC division, and they put us in that division. Well, the entire team quit because we didn't want to make PCs. We wanted to make bitmap workstations. So again, rejected, got married to, I picked the most beautiful woman in the Bay Area, and I married her, and that was the beginning of that. So we went off on our honeymoon. And when we came back, a good friend of mine, who was the best man in my wedding, had interviewed at this place called Amiga Computer. And he said, Carl, you should go interview at Amiga Computer because you would like what they're trying to do. And they're going to make custom silicon to help support this idea of bitmaps. They're going to have Blitter and copper and all this other stuff. So I said, but you should go interview for the manager of operating system position. So I went down there, and Bob Pariseau interviewed me. We talked for probably 2 hours. He said, when can you start? And I said, tomorrow. I'll start right away. This sounds so cool doing this. It's funny because I met Jay early on, but Dave Morris, who was the president of Amiga, he was off on a trip, so I actually never met him, and they hired me anyway. So got to know all the hardware guys fairly well, and then the software team was just coming together. We were waiting for like Dale to wrap up what he was doing at HP, and Sam Dicker, I think, or RJ, I think, was still working at Bally or whatever that company was that he was working for. Was 83, August of 83. August 83. I was employee number 28. Yeah, yeah. So this is the environment we worked in. I called it the cave. It was just one room, no windows, dark, really crowded, and we all jammed in there, and we really didn't mind because we all believed in this dream of what the Amiga could become. Personal computing back then really wasn't a thing. There were home computers, so Commodore dominated home computing. Okay, and this is before we merged with Commodore. Okay, we're just a separate little company. And but there was Atari, and of course, Jay Miner came from Atari. He's one of the inventors of the Atari chips, so he came from there. And then, we all got started, and it was just totally from scratch. It was like there was nothing to start with other than just our imagination and how we build this. And one of the things I wanted to point out is there's a wall that you see back there. So we were lucky that this office that we rented had whiteboards on all the walls, so we could do things. And in that wall, we ended up putting a diagram of what happens when you press a key on the keyboard to when it shows up on the screen. And that's the entire process, the data and code flow that happens on a multitasking machine that has device drivers for the keyboard, device drivers for the display. I mean, all graphics library for the display, all that kind of stuff. So it starts up here. You can barely see it. There's a finger pressing a key, and it comes down through here. And what you see in this section here, this is the I/O system of the Amiga kernel. So this is do I/O, send I/O, perform I/O, all those I/O functions that then pass the key along to where it then gets rendered. Fonts get rendered, and then put up on the screen. So that was done by Kodiak and I. So Kodiak's Bob Burns. He's not here though, right? Did he come? Okay. So great guy, amazing guy. Did the font, printer, all that stuff. A lot of things for the Amiga. Oh, so why did it say don't turn off that light, Dale? Well, I was wondering what so I took all these pictures originally. These are all my own photos. I don't know if Dale's even seen this. It says do not turn off on that light back there. And that's right by your desk. You're just sitting to the right of that. I have no idea why it said that. No, it just pointed against the wall. Maybe so when the lights got turned off, we didn't all fall over each other. That's all I can think of. Yeah. It's like what they put it on stage, right? That's right. Yeah, you're sitting right in front of that, aren't you? Your desk is right in front of that. Yeah. Yeah, that's probably rude. Yeah, so it's Mike Flickack, by the way. He's in those photos also. He's labeled Mike. He's here. We got Dale, we got Mike, we got me. Is there anyone else that was in that room? RJ signed up, but he's not here. So, okay. Ron was in the hardware lab, so he was down the hall. So I'm not doing the hardware lab, it's a whole other talk by someone. So there's the rest of the team, right there. The rest of the software team. Is that backwards? Yeah. Oh yeah, you want to see the names of these people? You know the names of all these people now? Okay, so Sam Dicker, we got Sam over here. This here's Sam Dicker, Bob Caruso, VP of software. You got Bob Burns, who's Kodiak. It's all Kodiak. Cheryl Gibbons, Cheryl Knowles. She did the hand that holds up, for the disc. She's the artist for that. Debbie Bernardo, Karen Michael. That's RJ's wife. There's me, Dale. Who's that? Is that your team? That's not your team. Where's that? You've seen the two. Neil's not that tall. Neil's not that tall, is he? Yeah. I don't think Neil's in his picture. Yeah. Do you remember who? That's Bear. This is Barbara. Okay. Barry. Barbara. It's like the president. Jack Hager. Yeah, oh yeah, Jack Hager. Yeah, for sure. He's the other artist that did a lot of the great art for me. A lot of posters and things too. And
this guy standing next to Bob Burns.
over here? Oh, yeah, right here. Very Sheena. Very Sheena? Could be. But no, I don't know. What was the name? It's a very. I recognize her.
So the team was dynamic. It was changing all the time. Not everybody's on this picture, but
yeah, this was taken at a point when I knew I was leaving. Okay, I got the whole company together. I got my camera on a tripod, and I took these pictures. There was, you know.
That's late '85 then, right?
Yeah, I think it's kind of mid '85.
Because I left in March '85.
Oh, you weren't in there? Okay, yeah. Mid '85, yeah. I thought I should at least take a picture of the company. Well, I took all the other pictures too of the company.
Point in time, you know?
At point in time, yeah. So the big exec was unusual for its time. Every other home computer just had ROMs. You entered into the ROM through, you know, address, 3000. You'd go and, that would put a character on the screen or whatever. So Amiga was quite unique in that it used libraries for all of that. The whole design, I was very object-oriented kind of guy. I knew we couldn't use an object-oriented language on this. The only one that's really around was, any serious one was actually Smalltalk, which you really couldn't use for this. This is before C++ and all that happened. And so I took this idea of taking this really small kernel idea, which is the concept of a node, right? And letting you link these nodes together in doubly linked lists. I did that first for just messages, and then I realized, oh, now that I've got that, why don't I use that for linking up libraries and keeping lists of libraries? Let's do it for devices. Let's even do it for interrupts. We'll keep lists of interrupts that way. And they all have a name, right? They all have a name field, so it makes debugging really easily. Can you say, show me all libraries, or show me all the devices, or show me all the interrupts? And they're also prioritized. They had a priority number in there, so you could, like for interrupts, you may want to have one priority, at a higher level to handle the interrupt before other things. So that all came together really well. It had a signaling, which was a super lightweight signaling mechanism, bit-based signaling mechanism. It also had this IPC layer through the messages. So you could do both. So a message could then trigger a signal, and that's how things worked. It's self-configured on boot, and that was a necessity because all of us were working at different parts of the project in the room. So Dale would be down in his corner doing graphics, and I think he actually, one of the first libraries was the graphics library that got put into the structure. And Sam was working on audio, RJ working on other things, and then you'd throw it into the ROM and try to boot it, right? And everything changed size and all this kind of stuff. So rather than hard code that, I actually had exec scan. It scans through memory and it looks for a signature. And if he finds that signature, it then says, this might be a library or a device, and then it adds it to the list. So it did that automatically, which was really a super good. And then it was very fast and low overhead. And that was necessary because we had game developers that wanted to use this for games. And I thought if it's slow at all, they're going to blow away the whole operating system. They'll just go right to the hardware. They'll ignore everything. You'll be incompatible. And so it's got to be like zero overhead to convince game programmers to use it. And so that was a tough one, but I think we accomplished it pretty well because almost all the games are friendly to the structure of the operating system, and they still work today, which is amazing. Yeah. So, and that's a date. This is a date. You might be able to find this out there. I could actually. These are the dates that everything happened. So this is when I started working on it. Was in September of '83, and then the first CES was just a hacked up version, and it was table based. The original version of exec was table based, and then I took all that out and put in lists, and then went to another CES, and it's kind of the development of it as things went along. And that's just sort of the structure. That's a slide I used for the second developers conference. So one of the funny things about multitasking is everyone knows what it is today. Back then they didn't. back then no one understood multitasking unless you were a computer science guy or you worked in some computer company or whatever. And I would tell people, oh yeah, we're making this multitasking. This is going to be a multitasking machine. And I got a lot of different reactions. The first one was, what is multitasking? You know, and it wasn't a word like it is today. You know, it wasn't like anyone saying, oh, I multitask, you know, and they don't even know where it came from. That word didn't exist in the vernacular. So, and then it was like, well, why do I want it? My dad even, he was like, hey, you know, he had a PC. Oh, why do I want multitasking? I just turn it off, turn it back on, put in another floppy disk and go switch on. And so it was like, oh, you don't need it. The game, of course, game machines, you don't use multitasking game machines at all, do you? You know? But in this one, you sure did. And of course, home computers don't even need that kind of thing. So, and then is it even possible? You got, what is, 256K. You were going to do multitasking, and in fact, we were. So that changed things. So now, this thing happened along the way where we hired a company called WSM Group out of Tucson, and they were responsible for writing the file system. And they liked the design of the Unix file system, which I thought, was a decent file system. So, and the API as well, right? And so they decided that they were going to go that route. We sent them machinery. We went and visited them a couple times, and not much was happening. They would give us a little bit of code, barely worked, and it was looking pretty dismal that we'd actually have a file system. So management got worried that we weren't going to make our release date without, a decent file system running, which it wasn't. What no one knows about is that Neil Caton, who'd just finished the disk driver was really slick for the Amiga because it actually used the blitter to be able to decode the disk, encode and decode the disk. It used the blitter, right? And also used the DMA channel to get it into memory. So it was a really slick piece of code. So the both of us went to Dave Morris and sat down and said, hey, Dave, we're willing to take a month, lock ourselves in a room, and Sydney didn't know this, and just make it happen. Just write it, a decent file system for the Amiga. And he's like, no, we're going to find something else. We can't spare you guys to do that. And, it's a management decision. It wasn't, I don't think, the best decision. So one day, this guy, Tim King, shows up, and he's sitting at Amiga, and it's like, hey, what are you doing here? He says, well, I've got a file system that runs on Amiga. I was like, oh, really? How did that happen? Where did you even get the API? Where did you get the Amiga to try it? Well, someone in management, I'm not even sure who, sent this off to him, and he got it running. And so I'm like, okay, if it's going to run on the Amiga, it has to work with exec, okay? Because exec is the base. Everything's written on exec, the basis for everything. It needs to run on the kernel, which was a challenge because for a number of reasons. One is they wrote it all on BCPL, which is a predecessor of the C language, okay? And it's a really kind of weird language. It has a different way of addressing. So it does 32-bit word addressing. It doesn't do byte addressing, which is what the Amiga did, byte addressing. So that meant that you had to convert pointers. Anytime you pointed into any Amiga code or pointed back out of Amiga code back into the file system code, you had to convert your pointers, which was really unfriendly. I mean, you'd use macro to do it, but still it was unfriendly. And if you did it wrong, you'd crash, and that was the big problem. The other thing that, so what happened is I actually went and took Tim King over to Saratoga. We locked ourselves in a room over there, and I said, you have got to change your API. It's way too ugly looking. He had something, the open function was called something like initialize input handler or something, and initialize output handler. Those were the names for the open function, right? And I said, let's just use the words that like Unix uses for opening a file. Let's call it open. And he agreed, which I was happy about. So we basically renamed all of his API to make that more friendly. But then he insisted that we needed to cache the floppy, and it was a debatable subject, right? So for performance, you want to cache. But the problem with that is if it's in memory and you pop the floppy out, it's not on the disk. And for a consumer machine, that was a mistake. because most consumers are not going to watch the light on the front of the floppy. They're just going to reach over and pop that floppy out. And that caused massive grief for everyone that used Amigas. And it was very embarrassing to me because people were like, oh, I destroyed my disk. What can I do? It's like, oh, it's going to be tough to recover. So, yeah, so that was one of the other big downsides. So the project moving along, we release it in Lincoln Center. It was like this wonderful, elegant event. Everyone was there dressed up. RJ and I were like, oh, we've done it, we've done it. And so that went well. That was a great event, and Commodore treated us really well with that. And then there's the whole team. So it wasn't just us in software. It really took, and that's a pretty amazingly small team when you think about what we created. So my last job was at Roku. The team was 10 times that size. So it was really quite an accomplishment for its time. Everyone is just so fully dedicated to making that product. So I'm done, and I'm thinking, what am I going to do next? Well, I wanted management to do. So Dale gets a copper, and Dale gets a blitter, and he gets all these DMA channels and everything. He got all the fun stuff, and I don't get anything. I got the 68,000, right? I want to have two 68,000s. I want to have, or two processors. I don't know if Dale remembers this, but I was constantly talking about the transputer. Transputer had just come out, and it's like, oh, see, this can communicate really well between multiple CPUs. And I tell Dale, we're going to make the transputer the next, CPU for the Amiga, next Amiga. So I went to management and pitched that idea. Rejected. It's like they were too busy, and I understand this. They were too busy just trying to get the product out, just trying to get it sold, just trying to get it manufactured. All the details that go into making and putting a machine on the market were all happening. You want to know who? Martin Shabilsky. Yeah. So Martin said no, and I argued. I came back many times because I said, I don't have anything else to do. I don't see any reason to stick around. I think I'll just take off, and I did. And I didn't have anywhere to go. I wasn't like another job. I just quit. Okay, I'm done. You guys are going nowhere if you don't step up to the next machine. So I was trying to push Commodore and push the Amiga team to do the next thing, which later happened with Commodore Westchester. They made a lot of great stuff. So things happened. I got this call. Cindy picks up the phone. She says, "Hey, there's a secretary on the line. Irving Gould wants to talk to you." Now, I know who Irving Gould was. He was the chairman of the board of Commodore, and he was one of the founders of Commodore. And he was out in New York, and he's a very, very wealthy guy. It was important to pick up his call, so I did. And he says, "You got to come back." I was like, "Well, no, I'm not coming back." It's like, "No, you got to come back. Here, talk to Henry Rubin." Henry Rubin was his technical translator that would translate for him anything technical into what Irving could understand. And and so, well, I won't go into the whole conversation, but it comes down to Irving then says, "Hey, give me your bank account number. Tell me how much money you want to see in your bank account. What do you want deposited in the bank account?" So I'm like, what could I say? I mean, could I say $1 million? This is quite the offer, to do this. And I was stupid. And I should have done it because I think I could have, maybe fixed some of the things that were wrong with the DOS. But, yeah, I resisted. I said no. I didn't even have another job. It wasn't like I was making money somewhere else. I just felt like it was beyond me. So a few months, my wife was supporting me. Yeah, she was working at HP, so I guess there was a job on the house. She was an engineering manager. Yeah. Good job. Thank you for pointing that out, honey. Yeah, makes it look a little bit easier. Yeah. So Sam Dicker had this great project going on at Apple Advanced Technology Group, and he recruited me there. And then in the meantime, I had met with Bryce and Nesbitt, who had taken over exec, and we did this mind meld thing, And we went in a separate room at a conference, and we spent 3 hours just mind melding, and he was the perfect guy to take over exec. I was so happy that Commodore had hired him because I felt it was in great hands. It wasn't going to get destroyed by somebody who didn't understand, critical sections or any of that stuff. So that was the same time that, you know, I eventually then moved out. You know, my first son was born, our first son was born. We decided to get out of the kind of the racket down there in Silicon Valley. We moved up to Mendocino County, bought some property, built a house, and the phone rings again. It's Irving. And he says, hey, we're trying to sell Amiga into Canada, and they require the logo programming language. So we don't have a logo programming language, so we can't sell Amiga into Canadian schools. And I'm like, oh, okay, well, I had been working with a guy to do this Amiga logo thing. It had flopped. He was in Los Gatos, and he had a lot of problems with his company, and it never happened. So I sat down and took about probably less than a year and created Amiga logo. And this, if you never used this, it was a really great product. I wrote the manual as well as the software, and I wanted it to work really well because that's what, you know, kids would be learning. So I wanted to be able to do a lot of color, sound, all this stuff. Great, great product. And so that was helpful for that. And I also wanted to get out more information about how the Amiga kernel worked. And so I wrote this little book. And I was going to do several of these issues. This is number 1, Guru Meditation number 1. And I was going to do like 8 of them. So I went and printed them myself. Here they are. If you want one, you can have one. I've got a whole box here of these. If you know who Pat Brulé is, he calls this the best book ever written on embedded computing. And he's the guy that did the toaster firmware. Okay, so this guy is rock and roll, and he loves this book. And it is actually, it took me a long time to write this book, but it's fun, and it's Amiga specific. You know, Ralph Babbel, is that his name? Ralph Babbel actually came out with a book that was equally amazing, his Guru book, where he went into everything. This one just goes into the kind of the kernel primary, you know, tasking, interrupt handling, all that kind of stuff. So I've got that. Let's see here. So I should say one thing. This is like a commercial break. I've come to a lot of these shows, not a ton of them, but I've come to a lot of these shows, and I've got so much Amiga stuff that's ancient. Okay, so I'm going to take a little break here and say, hey, I've got, this is like an original t-shirt from Amiga. You want it? Yeah, sure, it's yours. All right, so that's what we're doing here. Okay, who can guess what this is? If you can guess what this is? Sinistar. Sinistar, that guy over there. Dale, good guess. So Sinistar was the game that RJ built and wrote, and Sam Dicker, before coming to Amiga. And we'd all go play it. We were big fans of Sinistar. And it was a great game, too. Let's see if anyone can guess what this isn't an Amiga thing, but it's still pretty cool. What year did this happen? See who is paying attention to my presentation. Yeah, what year? I heard in 81. 81. Yeah, it's probably your kid's size. Yeah. Yeah. Okay, here's a real interesting tough one. This is detailed history of Amiga. If you know what this is, you know Amiga really well. And if you, so what's the story? Name the person who made this Dribble. What was the name? Glenn. You did? Okay, there you go. Did you get the T-shirt? You brought the T-shirts? You brought the Dribble. Dribble. Yeah, Dribble is a pretty cool product. Ahead of its time. Should have been a huge success. I guess it wasn't, but at least you got a T-shirt out of it. What about this one? Anyone know this one? What year? 87. All right, here's one of the toughest ones. You have to know CDTV to know this one. So I'm willing to actually take almost any. Who created this T-shirt? So Pink Floyd. Anyone recognize that name? So what was the Pink Floyd guy that was involved with the?
That's the Who.
One of the band members?
One of the band members. He had the studio for recording.
David Gilmour.
No, it's pretty close.
Sick Basic?
Scotty Page. Scotty Page. Scotty Page was a sax player, and he ran the Pink Floyd studio down in Los Angeles. Anyone want it? Who wants it? Who has it? Okay, you already got one. Okay, over there. Okay. So that's Scotty Page. Walt Tucker. He started a company called Walt Tucker because Walt Disney, and then he saw that Tucker movie, you know, about the car, the Tucker car. So he named his company Walt Tucker. And he had this massive, wonderful compound in the middle of Los Angeles where, you know, he recorded bands. And a huge mixing board, like about the size of this room here. Let me continue with the show and more giveaways at the end. A lot of times. Oh, did I explain that? Yeah. So what happens is I go to the 1989 Developers Conference in San Francisco. I run into this guy, Don Gilbreth, who tracks me down. He says, "Hey, we want to make a CD-ROM based Amiga." And I'm like, really? That's a great idea because I think, you know, CD-ROMs were just becoming a thing. Massive storage compared to what you put on a floppy disk, so you put, you know, endless number of games on your Amiga. And I thought, well, this is a really good idea. Who's going to drive it? Because you got all Westchester, you know, they're the ones in charge. And he said, well, you and I will fly out and we'll visit Irving Gould again. So I go out and talk to Irving, and Irving says, he says basically, Commodore started as a home computer kind of company. And it's kind of gone off and it's like a tool now, and yeah, in Germany it's more successful as a home computer, but I want success in the United States, again, as a home computer. So I want to make it something more you can put in your living room. And we said, okay, that's good. And Don was totally in on that. Don Gilbreth was the hardware side of it. He was the one that orchestrated going out to all these Japanese companies and getting them to contribute something. Whether it was the front panel, you know, all of these were done by different companies. The remote control, the front panel, the CD-ROM was still new. It's from Mitsubishi, and they had some bugs in it and stuff. And then Gail Wellington kind of ran the whole software developer side of it. You know, recruiting Amiga apps to put their app onto CD-TV. So I headed that up, and I know there's been like has it been like a movie or something, or a show that someone put together a TV thing about, I think, CD-TV, because they called me about it, and I gave them a little bit of information. But what I had forgotten is I've got like 3 boxes, legal boxes in the basement with every single document that has to do with CD-TV, including hiring people, firing people, schedules. I found this, it was incredible that I could find this. You know, because when he called me, I didn't have a whole lot to say. I don't really participate much in these, you know, sort of retrospective. Here it is. This is my calendar from when I was working on CD-TV. So it has like every meeting and every kind of decision that was made on CD-TV. I kept the log of it because I was actually getting paid for it. So I kept track of every single thing that happened, and so that'd make a good, you know, if they're going to do that TV show again, I've got this to go off of. It's much better. Plus 2 or 3 boxes of contracts and, you know, faxes. Back then you faxed everything, right? Where's that remote? Did I dump it in here? Oh, there it is. Nice. All right. So that project went really well from a development standpoint. We were up against what would they call that? The Philips, yeah. And what do they call that? CDI. CDI. They spent $2 billion, billion with a B, developing CDI. We developed this for, I don't know, 10 million or something like that for the original, you know, development effort. That's not manufacturing, but just developing it. And it was better, well, in a lot of ways, because it had the Amiga and had all those 10,000 games and things you play on the Amiga. You could pretty much put it on this thing. You know, you had to figure out a few things like what to do with a keyboard and that. So then that ended. The product was out. I thought it was going to be like massively successful. I thought this was going to be a good thing. So I wrote this authoring language to do demos and did a lot of demos and things. I created this I actually patented this thing, CDXL, which was basically scattered read from CD-ROM. So because the Amiga had DMA for so much, and because you could cut up the DMA into different parts of memory, when you read it in, you could have video, audio, code or text, and they could go into different parts of memory. And so you give it a list. You'd say, okay, I want you to read from the CD, scatter read it into these different spots. So it's super efficient at doing that. And one of the problems that was, I don't know if you used a CD-TV ever, but it would like grind away on that CD. You put in a CD and it'd be like, okay, when's it going to come up? 2 or 3 minutes later, it's like, ah. And it would drive me nuts because anything that I created for it, it instantly came up. So I thought, what are these developers doing wrong? Well, what they're doing is they're using their, floppy disk file system style for all of their data, and they're putting it just on the CD-ROM like that. It's scattered all over the CD-ROM. So it's having to move the laser around everywhere to pick off these different parts of these files, which is totally the wrong thing to do. You want to put them all next to each other so they all read off. So I created like 3 different tools to help them do that. I don't know if any of them use the tools. I mean, maybe a few of them. And it's really, you notice it on CD, TV when you put in something and it comes up right away and starts, it's playable, but they're rare to find. I was one of the few people that got Commodore to basically venture capitalize a company of mine that was called American Multimedia. And this was to take CD-TV and to use it for industrial purposes. Because it's a nice, compact machine, low maintenance. You could put a monitor on top of it, and you could have industrial training, essentially. And it seemed like a good market. We did a number of examples and demos and things to try to convince people to do it, but it was still too far ahead of time. These people are still doing dial-up modems and stuff like that. They just didn't understand it. So that market failed too. And along those lines, motion video is starting to come in. My company created this really nice motion video editor, and what I really liked is if you hook the trackball up to your Amiga, because I came from TV, right? So I'd seen these TV systems that use these trackballs to be able to do nonlinear video editing. I thought, I wonder if you can do that on Amiga. Well, actually, yeah, you can do that. You can do it really well. So I created essentially a motion video editor. We called it Bay. And then we found someone that wanted to buy it. And it was Macro System Germany that wanted to buy it because they got into this big time. And they had this Draco box and all these other things. And I think they're still doing it. I'm not sure whether video editing is still their thing or not. But what's funny about it is I really got to know Jörg Sprava really well and built the product, gave it to him, didn't hear anything else. There's no like, where's my check for all the development? Didn't happen. And then 5 years later, he gives me a call. You probably heard this. He said, hey, I've been massively successful with this video editor. I owe you something. What I promised in the contract. So he finally paid me, and I was very happy that I hadn't, misjudged him just late. So what's the final thing then? So there's this VisCorp Ed. So again, Don Gilbert comes to me, and he says, hey, VisCorp has got this great idea for a device, and actually it was a cool idea. You connect it to your TV, you connect it to your antenna, and it will decode the TV. It's then gen-locked, okay, with graphics, and then remodulated so it goes back into your TV antenna, and you can see all this stuff. And it's connected to a telephone plug, and it can go on the internet, and you can make telephone calls from your TV, and just all kinds of like cool integration of television, internet, TV all together. And in addition, there was kind of a sales pitch for putting ads on your screen. So, this is something that you see nowadays where in the corner of the screen pops up, get a discount, order it now, 20% off, that kind of thing. So a guy named Roger Remillard came up with all his concepts, and he patented them. And that's what this company, VisCorp, was based off of, that idea that was going to be a huge success. And one of the neatest thing about it is the front of this box. Here's one of the boxes right here. This is actually a VisCorp Ed. I don't know if you've ever seen one before. This is it. And if we have a museum here, I would be willing to donate this because I don't want to carry it around anymore. It's like, oh, Dale, what I was saying. Okay, You sold to Dale. Thank you, Dale. So it's a cool idea, but I think they had some management problems because I wrote a really nasty letter toward the end of my employment there that became very popular. And everyone in the Amiga community was really not happy with VisCorp, as I recall, because it was supposed to get all the IP for Amiga and it was supposed to do great things with it. It never happened, which meant that the next in line, Gateway Computer, said, hey, there's a lot of patent property here. Let's buy it. And so I flew down to talk to Ted Waite, and he was real excited to talk about it. And you went down too, right, Dale? Okay. So he's like, what can I do with Amiga? He says, Ted Waite, billionaire at that point, runs Gateway Computer, making massive numbers of computers. I said, well, it's got a lot of cool properties. And he had all, of course, his engineering team in there. It's like, yeah, but, it's not that great, blah, blah, blah. It's not a PC. It doesn't run DOS, all those, kind of things. And so I said, well, okay, maybe it's just the IP that is worth buying. But the funny thing that came out of that is when I went into his office to talk to him, he had stacks of paper on his desk that he was reading. And it was my Rebel manual for my Rebel language. So I created this language, Rebel, Relative Expression-Based Object Language. It was pretty cool, ahead of its time language. And he was reading all these documents, wondering, what are you going to do with this? And I said, well, I'm trying to do a startup company. He says, well, I'm putting together a company to do startup companies. And so that's how Rebel got funded. His first round was through Avalon Ventures, which was part of Gateway Computers' Tash Stash. And we actually, if you ever use Rebel or were part of that revolution, it was an amazing amount of cool stuff because you could write. It was really good at integrating the internet with code, much beyond anything like Python or any other of those types of language. It was, if you know JSON, well, JSON was Doug Crawford, and Doug Crawford loved Rebel. And I'd come down and visit him down here, and he'd say, you got to make Rebel open source so we can put it into the browser. And I said, I can't put it into the browser because it's IP. It's I'm not going to give the source code away. It's been too much of a project. He said, well, you got to do it. I said, no, I can't. So he wrote JSON for object exchange. And Rebel is JSON on steroids. I mean, it can not only do data exchange, but it can do code. It can do algorithms. It can do abstract stuff. And all of that gets you layers above in terms of expressibility. So, for instance, when you write a GUI, you could actually say, view, button, red, open, quote, open, and run it. And a GUI will pop up. There'll be a red button there, and you can press it. And then you can also put the code for it right next to it in square brackets. And now all that just worked really well. And if you wanted to send an email, it was another line. So, so that was a cool project, but it wasn't paying the bills. And actually, it was 15 years ago, Dale. You realize that? 15 years ago, I come to this Amiwest. Dale brings Roku Pico, which was this cool little box that was basically a full computer on a box, that was a Roku, player. And it was so cool because it was like, Dale, do you realize what we could do with this? This could be like the next Amiga or something. And he's like, well, you got to talk to Anthony. So I went and talked to Anthony, and he said, well, what do you want to do? And I said, well, I think I want to build one of those boxes. And did you ever consider making it open source or making it open so people can write their own programs for it? It's like, not really, but I don't know, maybe. So he said, would you be interested in making the lowest cost Roku possible so we can sell it in Walmart? I said, sure, let's work on that. So together, he and I picked the chip, and Anthony Wood and I picked the chip, and we got started on it. Very small development team, got it out in a year, and I went down, within a year, and I bought it at the Walmart in a little town that I lived in up in Northern California. And I was like, this is cool. Be able to make a product, get it to the, get it on the shelf in a year. So that was then 13 years, spent 13 years at Roku making all kinds of products. One of them was the stick, the Roku stick, which is an interesting story of how that came about, which was one of our big sales chains, a big store that made electronic things. They said, you know, we don't want to add Roku to every TV, but it'd be nice to have just some little thing, a little module, you know, you could plug in the side. And I was thinking about, you know, Atari had those little modules with the little fingers, and you just push it into the clip. And I said, yeah, that's cool. And so I wrote out a spec for what signals did we need to have on that little module to plug in there. Anyway, that evolved into the Roku streaming stick, and we patented it, and it was a big success because people didn't want these little boxes in front of the TV. They want to put them all behind and whatever, you know. And it was tricky in many ways because the power was really difficult. HDMI connector, if you know it well, there is power on it, but it's only like 50 milliamps. All right, it's not enough to run a whole stick with Wi-Fi and all that kind of stuff. So there had to be an external, you know, connection for power. Yeah, so that was that. Let's see, develop products. Oh, so then I retired 2 years ago, and now back full circle. I decided, hey, you know, computer software has just gotten there's so much gobbledygook, and C++ has gone off into outer space, and there's so much complexity in the world of writing software. I want to get back to something simpler and something that was more along the lines of what I did originally. So started a TV production company, and I've got a TV series I'm working on. Written 5 episodes of it. I'm going out, you know, trying to find producers to make it and studios to make it, and that is a hard gig. It's worse than the venture capital circus, because those people are all insiders. They're none of this open venture companies. They're all like, no, you can't come talk to us. We don't want to hear from you. And that's because there's so many people that write, you know, shows and scripts. They don't want to hear it. Anyway, so I've written that, but I've had some limited success in finding some people that are interested in doing it, to see if the conditions go right and all that, and you know, producers and things, and money sources, and yeah, and then there's this whole AI thing that's happening right now in this whole industry that's really messing up a lot of it, because they're afraid it's going to take over, and it might, if it gets good enough, it might take over a lot of it, but can it really do it? You know, we're not sure. It doesn't need the human element, all that kind of stuff. All right, so I think that's it. I'm going to need to get some water. Oh, I got some T-shirts, more T-shirts to give away. I can take questions too, if anyone's got any questions about any of this sort of the full arc type idea. Let's see what I've got.
All right. What year was this?
88.
You got an 88.
84.
Who said 86? I see that. You got the inside track on that. Yeah. All right. What's that? Oh, thanks. About water? Where did water materialize from? Any other questions on things? A lot of people thought that the Amiga kernel came from something else. You know, it came from Unix, or it came from some other university project, whatever. It did not. It was actually something I developed prior to coming to Amiga. I took it at HP. By developed, I mean I developed the concepts of it. I didn't develop the code. And then coming to Amiga, that offer that they gave me, you can do whatever you want, come here, do whatever you want. And Jay Miner actually challenged at one point. He came to me and said, hey, here's Day-Ray Atari, which is the book that's written about the Atari OS and how it worked, what OS wrong for the Atari. And he said, maybe you should do something like this, because I don't think we really, bought into this whole, we're going to have this, multi-APIs and libraries and all that kind of stuff. And I said, well, I'll look at it, and I took it, and I considered it, but no, it had to be the way it had to be to really launch, all of what was built with the Amiga. It's just the right decision at the right time in history. Oh, here's an Amiga logo. Does anyone want an Amiga logo?
Yes.
I got a lot of, okay, what year was it? What year was it?
Oh, 89 or 90?
Yeah, 89 is correct. The copyright on this is 89.
Oh.
So it goes back here.
And here. Yeah, here it is.
And sign any of this stuff you want later. You know, if you want a signed version of it.
Beautiful.
I've got a lot of stuff, and I got to tell you, I need to find someone who archives things. I keep carrying these boxes to these shows, and then I carry it all back home. And it's like, no, it's going to go in the garbage one of these days, and it's going to be gone forever. And anyone here write Rebel? Any Rebelers in? Yeah. Oh. You might already have one of those, but there's another. Thank you. Okay. All right. What year?
86.
Okay, here we go.
I said 86 too.
Okay, sorry. Yeah, developers conferences were good for all that kind of stuff. Here's Exec. If anyone wants it.
Oh my goodness.
I have one up back here. You want it? So this is the source code to Exec as of version 23.
No way.
It's annotated, signed by me, so you know it's official. It has the dates on it. It's the entire source code, and I actually wrote really well documented source code. Yeah, this is a work of art. So I'm glad you're interested in it. Thanks. Yeah. I've got another one. Stop any one. What's that? Computer Museum. Yeah. That's why he's a good choice. Right.
I guess that answers my question. I had a question for you was like, do you have any source code of historic interest that would be good to, there it goes, you did. Okay, now you don't.
I've got one more of those. So I've given one of those away before, because we didn't print very often. We didn't have a great printer or anything like that. So,
please upload to get it out.
Yeah. Okay, Heroes Guides. Anyone? Yes. Okay. Well, I guess we're over. Come on and get them. Yeah.
So, with the head of project,
I can't believe it. Did you see it?
That's 1986. That's when that logo was being used at Apple. That Apple was purchased. That piece was purchased at Apple. AT&T, yeah. Tesla, yeah. That's what you worked there?
no, I did not, but I met them about 3 different times.
Yeah.
The early 90s after he had gone off.
Yeah.
So, well, even though you were still there.
Larry Tesla ran.
Some really cool stuff.
Yeah. From Xerox Park. That's where it came from. And we had a big team from Xerox Park at the time. Yeah. Okay, so are you done?
I'm sorry?
Yeah. Anyone who has a collection wants any of these t-shirts. If you're CDTV or I got CDTV sweatshirts. These are newer. These are not so old. These are not 40 years old. These are from, I think, 10 years ago. History of Amiga.
I remember seeing it on
This is the one
he talked for almost an hour and a half about
Who wants it?
searching out
I'm giving you several already. What else?
and how it was going to change the
T-shirt.
I think at the time they were still working on this thing called Apple Search and how it was going to connect to music servers and all this other stuff. The guy was
Excellent.
I don't know how he ever took profit, but he was a smooth guy.
May I?
Yeah. Sure.
It's all I can work.
Okay, yeah, that was, yeah.
That makes it even more fun.
Here's the European Developers Conference. This was in, yeah, so that was, what city was it? Milan. You want to go Milan? Yeah. Milan, okay. There we go. That's a great conference. Oh, excellent, thank you. Yeah, my wife is noticed that.
Back, it says there's something back here, Amiga ambassador.
Oh, sweet.
We're all Amiga ambassadors.
Thank you. I appreciate that. Okay.
So
Everyone's got a Bruce guy, right?
Finnish, Polish,
Good?
and
Okay. Gotta find the other ones here.
Oh, cool. I'm Dale. So a couple things that add to Carl's conversation, beautiful conversation. Sinistar, there's a great documentary about Sinistar. So if you go on YouTube and Google for Sinistar documentary, there was a 2.5-hour documentary and featuring RJ and Sam Dicker and Jack Hader and a bunch of other people. You should watch it. It's great. They talk about it.
Exact. Sinistar has a microkernel in it. The other thing is we're trying to set up a little demonstration over here of Carl's debugger ROMWAC. Or I have a terminal and one of the old black and white or black metal debug.
Yeah. I'll explain it real quick. So the question is, your app crashes, your code crashes. You don't have a debugger. You're not running out of debugger. What do you do? Well, the Amiga had a debugger that was in the ROM. It's the smallest thing I could possibly make. It was like 3 or 4K is all. And it had a number of commands, but it'd give you enough that you go in there and poke around in all your variables and all your code and figure out why did I get like a bus error or that kind of thing. So Dale's got that running back there. It's kind of cool, fun. Pretty much really, it's guru level type stuff.
You're talking about CDTV and CD32. There was another competitor, 3DO, was working on a CD-ROM based machine, and 3DO also has a lot of Amiga history in it. I wrote basically it was another version of Amiga exec with resource tracking. Trip Hawkins. Here.
Yeah, Trip Hopkins from Electronic Arts started that company. Well, thank you, everyone. Appreciate it.